Hello, I'm Teacher Omar. Let's talk about potential and kinetic energy. These are the specific learning objectives from the most essential learning competencies. At the end of this lesson, you should be able to recognize situations in which work is done and infer that any object that has energy can do work. Differentiate potential and kinetic energy. And lastly, compute for the amount of energy possessed by a body with respect to its position and motion. Let's have a quick review. In the previous lesson, you learned about the Newton's three laws of motion: the law of inertia, the law of acceleration, and the law of interaction. Specifically, in the first law, you learned that force can change the state of motion of an object. If an object is at rest, it can be moved by exerting force on it. If an object is moving, it can be made to move faster or stop by applying force on it. The first law of motion has something to do with our lesson today because you will investigate the direction of the force and the motion of the object in order for you to recognize situations in which work is done or no work is done. But before that, let's define work. In physics, work is an abstract idea related to energy. When work is done, it is accompanied by a change in energy. When work is done by an object, it loses energy. And when work is done on an object, it gains energy. To explain this, let's have situation. A girl pushing a chair. She applied force to move the chair. Therefore, work is done by the girl. As the girl pushes the chair, she loses energy. Now, look at the direction of the chair. It moves from one point to another when the force is applied. Therefore, work is done on the chair. As the chair moves, it gains energy. In order to say that work is done on an object, there must be force applied to it, and the object moves in the same direction of the applied force. Now, let's have situation. Is there work done in this situation? A girl pushing a chair. Look at the direction of force and the direction of motion. Is there work done? Yes. Work is done if there is a force applied on an object and the object moves in the same direction as the force. Another situation. Is there work done on this situation? A boy pushing a wall. Look at the direction of force. Did the wall move? Is there work done in this situation? No. No work is done if the force you exert does not make the object move. Is there work done in this situation? A waiter carrying a tray. Look at the direction of force and the direction of motion. Is there work done on this situation? No. No work is done if the force you exert does not make the object move in the same direction as the force you exerted. Now, remember this. Work is done if the force applied on an object and its motion are in the same direction. This is your work. Investigate the direction of force and the motion of the object to the situations below. Identify each situations whether work done or no work done. Work is the product of the force applied on an object and the distance through which the force acts. In equation, work is equal to force times distance, wherein work is represented by capital letter W, force is represented by capital letter F, and distance is represented by small letter d. The unit for work is joule, the unit for force is newton, and the unit for distance is meter. Remember, 1 joule is equal to 1 newton meter. The unit joule is named after the English physicist James Prescott Joule. This is also a unit of energy. Let's have sample problem. Randy's backpack is full of books, weighs 30 newtons. He lifts it from the floor to a table 1.2 meter high. How much work is done on his backpack? So, sa pag-solve ng problem na ganito, we are going to follow the 5 steps. Step 1, identify the given. So, doon sa problem, we have here 30 newtons. And newton is force. So, you write force is equal to 30 newtons. Next, we also have here 1.2 meter. That is the distance from the floor to the table. So you write distance is equal to 1.2 meter. Next step, we have required. So ano nga ba ang hinahanap sa problem? How much work is done on his backpack? So ang hinahanap ay work. So you write work. Next step, step 3, equation. Sa equation, you are going to write the formula for work. And the formula for work is equal to force times distance. Next step, solution. Sa solution, we are going to substitute the given kung ilan ang value ng F at ilan ang value ng D. So, work is equal to force. Ang value ng force is 30 newtons. At ang value ng distance is 1.2 meter. Then last step, answer. Compute for your final answer. So 30 newtons times 1.2 meter is equal to 36 newton meter or 36 joules. And that is your final answer.